Right, so in another video I'm doing a job in brass, and I've got a bit of brass bar to cut, which I'll be using this saw for. But before I do that, I want to change the bearings because they're getting a bit wafty. Now this is a saw I bought in auction, and I've used it quite a few times. Doesn't get used a lot. It's a Sealy, and it's described as a cutting bandsaw. It's rather good that it cuts, because as a bandsaw, if it didn't, it would be pretty shit. It's a model SM5 version 3, made in 2014. Now, any and everybody who retails these, I'm sure you can even buy exactly the same one in Harbour Freight in America. It's just a generic Chinese thing that's knocked out in their thousands. So anyway, in this video I'm going to change the bearings above and below the table. I've got replacement bearings, which are I picked half decent quality ones, and they are the bearings. Whether they fit yours or not, best you check, but these are the one for mine. So I'm going to take the table off and replace the ones above and below. Now, when I got this, it came with a couple of accessories, 2 lengths of stop, which I think in itself is a bit odd, but a short one and a long one. And with it came this bracket. No idea what it's for at all. I've got no instruction manual with it, and this sort of obelisk kind of looking thing. It's made of plastic, so again, anybody enlighten me what these are for, or whether they're nothing to do with it, I don't know. But anyway, at the end of the video I'll tell you what tools I used. Obviously at the moment I don't know. These screws in this table here are posi screws, but they're not the original screws. I didn't have the original screws. When I got it I had the plate, and as I have a larger chop saw, an old-fashioned donkey saw, a rotary one, this gets used more with the table than anything else. I will say, I hope I'm getting all this in shot, because I can't see anything because I'm facing the sun. So anyway, these screws are posi, but I suspect the original ones are probably Phillips, but exactly the same. Right, so lower ones, and I'm going to try and get away with doing these without taking the blade off, but the chances of that are it's going to come off anyway. I will slacken it off a little bit, and we'll see how we get on. I've got an airline here and I'm just going to blast any crap out of the way. Right, I'm going to cut to the chase here. There's no point in letting the video roll and you watching me fart arse around and just get nowhere fast. You need a 17mm combination spanner, a 12mm open ender, and a 14mm combination spanner. First thing you need to do is slacken the 17mm bolts here, here, here and here, and with a 12mm spanner open end here, and the same on each bearing, you can move the bearing away from the blade. They're on an offset cam, so you'll turn it and you'll move the blade away. That will slacken the grip on the blade. Then you need to remove the 14mm bolt here, top and bottom, and take the head units completely off. Right, got a lot going on at the moment, and
I need the saw desperately, so I'm going to be cracking on. Not going to be doing a lot of talking. If I need to do any talking, I'll try and do it on a voiceover. Got the new bearings.
Right, basically I had a bit of a cold, so you could probably hear my voice a minute ago was really rough. Anyway, first thing you need to do once you've got the assembly in your hand or on your worktop bench or wherever you want to do it, circlips off. Now I really could do with a decent set of circlip pliers because the ones I've got are crap. Anyway, circlips off. 17 and 12mm spanners to remove the adjuster axles. Yeah, of course you might have these already slack, so just remove them from the cradle. Next you want to drift out the centre pin. Now I just drifted it out as far as the bearing become loose, rather than drift it all the way out, but it's a bit of an awkward shape, and you might have to force support it, maybe even put it in a vise, but one way or another just drift it out until the bearing drops out.
Right, I found a well, it was actually a bar with a hole drilled in it and it's perfect size, so I've just cut the rest of it off, because what I can do is when I drive that in, I can slip that into the far side and it will support the bearing as I knock it in, and hopefully I can just pull it out. I shouldn't think this gap is mega crucial, because even on this one, don't know whether you can see or not, but it's closer this side than it is this side. But as long as it's in the middle-ish, I guess that's okay. Right, bearing.
Right, now put the bearing in place and drift the pin in through the bearing, and it wants to enter the housing just a little bit on the other side, and then just knock it back just enough so you can get your shim between the housing and the bearing. Now I've just used you could use a washer or anything here, and then just drift it back in all the way. Now once you've drifted it back in, check your bearing and your pin, make sure they're tight. If the bearing's loose on the shaft, I'm not so sure what you can do about that, other than maybe take it apart and pop in a couple of washers on the shaft just to keep the bearing in the middle. If the pin's loose, then you could probably just pin it over either end with a couple of centre punches marks just to hold it in place. Next, the axles. 12mm deep socket. Just drift a pin through into the socket. Make sure the socket's deep enough and it's got a throat that's wide enough to take next nut deeper. Right, get your new bearing, put it on the shaft and just tap it in on the centre of the bearing. Don't use the outside of the bearing, just the inner part of the bearing. Get a socket or something else that's going to fit over the shaft, tap it on. Remember, make sure you're hitting the inner part of the bearing, not the seal housing or the outer race. You just drift it on until you can get the circlip slot visible, and don't throw it on the floor. Next, put a circlip on and do this for all the axles, obviously, otherwise it's a bit pointless, and reassemble each unit.
Right, back out with the saw, and I'm trying to get you in a position where I don't need to keep moving the camera because I haven't got time, but you can still see what I'm doing. So I'm just making sure bits and pieces are clean, and this is the top one. Surprisingly, there's a lot of slack in that jaw. I thought that would be a lot tighter than that. Yeah, even though they machine a slot here and here, and it's supposed to line up with these, if you can see that slot or not, there's machined recess for it. It is so sloppy on there, it's unbelievable. I don't know if this one's going to be the same or not. Yeah, see, that's how much slop. It's almost absolutely pointless, to be fair. So what I've done is I've just pushed it against one side of the slot. Hopefully that will keep it straight. I'm on my mark. I'm just going to do it up tight and keep fingers crossed. Right, bottom one again. Right.
Now, it took me about 20 minutes just to keep the blade on, so I'm not going to show you that filming because it's just pointless. Instead, what I'm going to do is talk you through what I did to keep it on and then true it up. Now, I found it always wants to split the blade off on the bottom pulley, and it's the bottom roller set which is really the crucial key element here. The first thing to do is adjust the pinch rollers. They need to be tight on the blade, but not so tight that you can't actually turn it against the blade. Power off, mind you. Don't go trying to do that with the bloody... well, you'll be the dickhead that loses your fingers. So yeah, unplugged, I managed just to turn the bearings against the blade. If you over tighten them anyway, it will push the blade off. So definitely don't need them that tight. But say, just so you can get hold of a bearing and just about turn it against the blade. That's what I found suited my machine. With that adjusted top and bottom, I moved both the carriages back a little bit, so they weren't actually, the blade wasn't pushing against the rear bearing. This probably proved to be the right thing, because I found in the end I wanted to keep the bottom roller just off the back of the blade. I mean, literally half a millimetre at the absolute maximum. And it used to just, it would sit there, and of course when you're sawing it pushes it against the bearing. But literally I've got about a half mil gap on the back of the blade to the roller. The top one not so crucial, but I've done the same as the bottom on mine, and after doing that it would run and stay on. So it was a matter then of squaring everything up. Now, the project that I needed this saw for, which I've done this part of the project, cutting brass, I was going to use the table rather than the saw, its mechanism itself. So I wanted the table fitted on. So that's what I squared everything up with. The bottom blade I didn't adjust at all. The top one I adjusted to get it square. I put a square on the table and I eyed the blade up vertically with the edge of the square. And the top one I think I adjusted out slightly, so it was in line with the bottom one. Then it was just a matter of checking vertically, and there was no problem with that at all, and really there's no adjustment for adjusting it vertically. As it happens, it was dead nuts on. After that it seemed to run square, at least cutting on the table. Cutting as a bandsaw with the vice, built-in vice, that seemed to work alright for me. There is ways and means of squaring that up if it doesn't, but for my needs it seemed to work okay, and I was primarily going to be using the table, so that's what I did. So I'm going to leave you with some video shots of me just cutting some aluminium and some brass, and give me a thumbs up, subscribe, ring the bell thingy, all that shenanigans. Hopefully you found this useful, and I'll see you again on the next video. Ta-da.